Okay, so with our notes books at chapter 7, 8, notice for this chapter we've done chapter 5 so far, where we introduced the unit circle. We've done chapter 6, where we did non-right angled trigonometry. So we learnt the sine rule and the cosine rule in there. And now we're on to chapter 7. And in chapter 7, we're going to look at the sine function and the cosine function. We'll develop some understanding of what that is today. So in 7a, we just have the definition of what constitutes periodic behaviour. So we can have a read here. We have a function is said to be periodic if it repeats itself in a horizontal direction over intervals of the same length. So that's quite a technical definition. But if we look at the graphs that we've got here, the first function is not periodic because it's not the same in the horizontal direction. Whereas the second function is periodic because it does repeat itself in the horizontal direction. Okay? The first one's not because it's tending upwards. The second one is because it repeats itself over and over and over again. So in exercise 7a in our textbook then, we're just going to have a bit of a group discussion about which ones are periodic and which ones aren't. So exercise 7a on page 171, so we'll just ask you guys. A, maybe we can start having a look with Lincoln. Can you see A there? Is that going to be periodic or not? Does it repeat itself?
Yeah.
Yep, that'll be periodic. Good. B, Harry?
Yeah.
Yep, that's periodic. C, Riley?
Yeah.
Yep, that's periodic because it's repeating itself. Okay, how about D, Merlin? A tricky one?
No.
No, it's not because it's tending upwards. E, Andrew?
Yeah.
Yes, that's periodic. It repeats itself. Sound, F?
Yeah.
Yes, it repeats itself. Rainey, you've just arrived. Maybe we'll jump to Bree. G? No, it doesn't. Good, because it's tending upwards. And then H, and Vita? It's tending downwards, which means it will not be because it's not repeating itself in the horizontal direction. Good work, everybody. Okay, so that's periodic behaviour. What we're going to do next is we will talk about 7b, but we're going to generate our own sine graph first. So can we flick over to this page here where we've got a grid and we've got some angles at the top and then sine of the angle at the bottom. And we're going to pull our calculator out and we're going to put it in radians. Okay. So we've got sine, we've got theta, and then sine theta. And we've got 0, 1, 2, we've got pi on 2 in there. So 0, 1, pi on 2, 2, 3, pi. Okay. And sine theta. And it goes all the way up to 10. So we're going to start by filling in this table. Now the way we're going to do that, we're going to put our calculator into radians. Okay, so make sure, Merlin, our calculator's set in radians.
How do you do that?
So shift menu. Okay, shift menu, and right at the bottom where it says angle, it'll say radians. We want it to say radians. Everyone okay? Cool. Flat batteries maybe? Or? Okay, I'll come and have a look in a moment. You can borrow mine while we're doing this. So, alright, so what we're going to type in first is, here's the angle. We're going to type in what's sine of 0. So we're going to press sine 0 in our calculator and we're going to evaluate it. When the angle is 0, sine of 0 is 0. Now we expect this to be the case, right? Remember on the unit circle, sine is the y coordinate, and if the angle is 0, we're talking about here, here, the y coordinate is 0. Then we'll go to sine of 1, so I'll type in my calculator, sine 1, and I've got 0.84. Alright, then we go to pi on 2. Now pi on 2 we're going to put into the calculator. If you evaluate it, it's 1.57. And remember pi is 3.14. 3.14 divided by 2, 1.57. So that's where we're getting that number from. And sine of pi on 2 is 1. Alright? And of course pi on 2 is here. The y value, sine is the y value, so sine of pi on 2 is 1. All right, I'll pause there. I'll get you guys to fill in the rest of the values. Shouldn't take too long. Just press record there. We've got a graph that looks like this. In fact, we'll notice, and Vita, it's periodic. It's going to repeat itself in that horizontal direction. Now what I want to do, so we've drawn that out using sort of our calculator and a manual technique. What I want to do is show you this like demonstration up here. So if we can all see the screen there. And I'll show you these two videos first that are sort of generating it. So, hang on, we've skipped a couple of links here. We just want the initial one, sine curve and sine wave. So have a look at this video. All right, and what we're doing here is we have the x-axis. Okay, the x-axis is the angle, and then we have the y-coordinate here. So I'll press play, and we'll see as we're moving around the outside, the angle is increasing. Remember, this is our angle here, and we're just plotting the y values. This is exactly what we've just done. Okay, so we're demonstrating it with a stationary unit circle. All right, and so we're going there the whole way around. We're going 2 pi radians around, and we can anticipate if we were going to keep going around, it's going to repeat itself more in that direction, and we can even have negative angles in this direction. So let's just have a look at this one too. Okay, so this shows you with the unit circle moving. So notice how we're getting the y values on the outside of the unit circle according to the angle that it makes with the plane. Very good. Okay, let's even have a look at this one. This is quite a good one. This is the sine function. And what we've done is we're moving around the outside of the unit circle. Okay, so as I move it, as I move that point, this is our angle. All right, so it tells you your angle, and it's telling you the x and y coordinates on the outside of the unit circle. Okay, then it's telling us what's the sine of our angle, and that's what we're plotting. Okay, so the sine of the angle is what we're plotting on the x-axis. Now notice that the sine of the angle, as the angle increases, it's moving along, it's making that periodic wave, and we expect it to be a wave. We can keep going around and around and around, back the other way as well. It's periodic. We expect it to do that because as the angle increases, we're just going to keep going around, and the largest the y value can be, the highest it can be is +1, and the smallest it can be is -1. Okay, that's a sine function. So what we'll do now is we'll flick to our 7B on our notes, and we'll talk about how the sine function works. So we got 7B, the sine function, and I'll just draw a few things up here so we're all on the same page. Okay, so we have a wave, and we have a peak, a trough, and then a peak. Principal axis, and we have a wavelength. All right, very good. So we've got a number of notes here. I think I'll just pull out that the wavelength is 2 pi on top of B. So what we have here is an understanding of waves. Maybe if you've been doing physics, you've already had a little bit of a look at some waves, or you're going to start looking at them. But here we have some important properties. Firstly, we have what's called a peak and a trough. Okay, so those are sort of your maximum point and your minimum point on a wave. Then we have what's called a wavelength. Now the other word we use for this is the period. Now that's the length over which a wave travels, and it's going to repeat itself. So the wavelength is a distance from the peak to the peak, or from a trough to a trough, or you can think it's the distance for a whole peak and a whole trough, right? That would be one wavelength there. All right, from there to there would be one wavelength, because we've got half the peak there, whole trough, half peak there. So that's what a wavelength is. It's the distance for a whole period to occur. We also have what's called the amplitude, and the amplitude basically means the size of the wave, all right? And amplitude is this distance here. We call it the distance from the principal axis to a peak or the principal axis to a trough. That's going to be the amplitude. And the principal axis that were there, that just means the line about which the wave propagates itself. Okay, it's the normal line, the line about which the wave will hover. All right, so that's a number of points from here. I've got some tips on how to use your calculator to graph it, because in this exercise we will largely use our calculator. So let's move on to the first one. What we might do, we're just asked to calculate the wavelength. So let's just look at some calculator skills, how we can graph the sin x function in our calculator first. So can we go to the graph mode in our calculator? And in y1, we're just going to graph y1 equals sine of x. All right, that's the function that we are going to graph. Okay, now, can anyone tell me what's the number I've got out the front here? It's invisible. 1. Okay, there's an invisible 1 out the front here. What that means is the amplitude of this function is 1. So that means the highest we expect it to go is 1, and the lowest we expect it to go is -1. All right, so we can already start to think of our V window. So we're going to press Shift and V window. And these are the settings that we're going to have for X min, X max, Y min, Y max. Now for most of these, we're just going to graph between 0 and 2 pi. That's going to be one rotation of the unit circle. So we'll have X min is 0, X max is 2 pi. And our Y min and Y max is going to be directly proportional to the amplitude. Now what I mean by that, I'll show you what I mean. For now, we said the lowest it can be is -1 and the highest it can be is +1 because our amplitude is 1. Okay, so if we sketch this, all right, and we've got those settings and our calculator's in radians, here's exactly what it's going to look like. Okay, can everyone see that? I want to make sure we've all got that same calculator skill there. So V window from -1 to 1. Any issues? I'll float around any issues. Okay, good. Good. Excellent. Okay, what we'll do next then is we're going to change the amplitude. All right, so we might even just keep y1 as is, but in y2, let's sketch the function 3 sine x. Okay, so if we're sketching the function 3 sine x, this is going to affect the amplitude. Now the amplitude is not 1 anymore, it's going to be 3. So that means our y min we need to change to -3 and our y max to +3. And if we sketch both of these functions on the same axes, what we'll see is we've got 3 sine x here and we've got 1 sine x here. Okay, that number out the front, all it does is dilate it by a factor of 3. Now we've sort of seen some of these skills in F, but I want to emphasize, right, y2 is equal to 3 times sine of x. So if here the value is 1 and you multiply it by 3, of course all you're doing is stretching it in both of those directions, right? We're stretching the positive part that way and the negative part that way. So the 3 sine x is going to be the big one, the 1 sine x is the little one. Can everyone see that on their graph? Okay, really good. So that's the first thing that we're learning about is amplitude. The next thing that we'll learn about is going to be the period. So we have the wavelength is 2 pi, and I'm going to get rid of this and we'll just focus on 1 sine x again for now. So I've got 1 sine x. The other function that we'll sketch in y2 will be sine of 2x. Okay, so here's 2 pi and here's pi. So let's sketch that and see what we observe. Sine of 2 pi. If we sketch, sine of 2x. If we sketch sine of 2x, we will get this function. Okay? Has the same amplitude. I haven't drawn it high enough. It has the same amplitude, but what we should notice is that rather than there being one wavelength, there is two wavelengths. Very interesting, right? Sine 2x gives us two wavelengths in 2 pi. How about sine 3x? Okay, let's sketch sine 3x. If we do that, we will have 1, 2, 3 wavelengths in 2 pi. So this is fascinating because the value of b here, this coefficient of x, that tells you how many wavelengths there will be in 2 pi. Very good. So we've got how b affects it. So let's move on to our examples then. We have calculate the wavelength of the following. Okay, so the first thing we're going to do is the formula. We have the wavelength is 2 pi divided by b, all right, where we have a sine of bx. So a is the amplitude, b is the coefficient of x. So in our example here, if we have sine of 2x, okay, this is example A, if we have sine 2x, the value of a is 1, the value of b is 2. So to calculate the wavelength, we're going to be 2 pi divided by 2. And when we simplify this, we will get pi. What that means is for the function sine 2x, the wavelength, the distance for one wave is pi. Now we observed that on this graph here. We had 2 wavelengths in 2 pi, which means we have 1 wavelength in pi. Okay, let's move on to b. We have sine of 3x. The wavelength will be 2 pi on top of 3. We can't really simplify that any further, so the wavelength for c will be 2 pi on 3. Sorry, that's for part B. For C, all right, for C, just grab this quickly. Hello, Dennis speaking. It's her classroom, but yeah, I'm in here. Yeah. Cool, no worries. Yeah. Alright, so where we get up to C. Now the other thing we want to point out is we saw here with sine 2x we had 2 wavelengths in 2 pi, in sine 3x we had 3 wavelengths in 2 pi. Now we're at sine of half x. Now we've written a sine of half x. So that means we expect half of a wavelength in 2 pi, right? So if here's 2 pi, we expect half of a wavelength in 2 pi, which means we would have a whole wavelength in 4 pi, okay? That the whole way along would be 4 pi. And we can see that using the formula. If we do 2 pi divided by a half, that will equal 4 pi. Okay, good. So that's C. Let's have a look at D. Now we will ask it like this to you. In D we have sine of x on top of 5. Now whenever we write it like that, x on 5, we want you to think of it like this, sine of a fifth of x. They mean the same thing. And particularly later in semester 2, when we're doing some calculus and even index laws, we always want to think of fractions like that. It's not x divided by 5, rather it's 1 on 5 times x. Because now we can very clearly see the value of b. Now this means as well, okay, we saw 2 means 2 wavelengths, 3 means 3 wavelengths. Here we have half means half a wavelength in 2 pi. X on 5 means 1/5 of a wavelength in 2 pi. So that means the actual wavelength, and by the way, the symbol for wavelength is this. You can use that if you're doing physics, you'd be familiar, that's lambda. You can just write the word wavelength, okay, wavelength. the wavelength is 2 pi divided by the B value, 2 pi divided by 1 on 5. In this circumstance, the wavelength will be 10 pi. It's an enormous wavelength. Alright, that's D. Then we're on to E. E we have sine of pi x. So the wavelength is going to be 2 pi divided by pi, which equals 2. What that means is it will be 2 grid units for a whole wavelength. Okay, so today in the lesson, guys, we're doing exercise 7A, 7B.1. Now, we've already gone through 7A, we discussed it. So let's all flick to B.1 and I'll just talk about how we're going to solve it. So we're on page 176 in our textbook. Now, we're going to draw some graphs, and in the textbook it says without your using technology. I'm going to say using technology, okay? And we will be able to answer there question 1, 2, 3, 4, and 5. Once we've done that, we can do some folio. All right, so that's page 176, 7B.1.